Getting started. Here we go. So today we're going to solve problems and prove theorems about triangle proportionality. It just means we're going to be writing more proportions. The math that we do today is going to be the same math we've been doing. As long as we can write the proportion correctly, we cross multiply, we solve. That's about it in terms of the math. So let's get working. Let's go 487. 487. All right. Leo, you ready? There we go. All right. So when a triangle contains a line that is parallel to one of its sides, the two triangles formed can be proven to be similar using the angle-angle similarity postulate. So basically, when you have a midsegment creates a similar triangle to the large triangle, which is why we can then write things in proportion. What else do we have? Because the triangles are similar, that means the sides are proportional. So the math that we're going to do today is the same type of math we've been working on recently. So the triangle proportionality theorem states that if a line is parallel to one side of a triangle and intersects the other two sides, then it divides the sides into segments of proportional length. This is not something that we saw in the warm-up. There's nothing mentioned here about mid-segments. So we'll see mid-segments a little bit later. We will see mid-segments once we get to like example 3 pretty much. So we're not going to be dealing with what we saw in the warm-up until then. So we got some different things until then. So it actually divides the sides into segments that are proportional. So this is something that's going to look a little bit different. The math will be the same, but the way that it appears on the paper with the triangles will look slightly different. All right. Then it says if a line, second one here, the converse of the triangle proportionality theorem. So it says if a line intersects two sides of a triangle and separates the sides into two proportional corresponding segments, that means that the line is parallel to the third side. So if it's parallel, it creates proportional segments. If you have something connecting and it makes proportional segments, that means you have two parallel lines in your triangles. That's what it's saying. So first example. We have a triangle, and we're going to use that proportions to find the length of the side. So in triangle BCD, BCD is the large triangle here. Segment PQ is parallel to segment CD. We can see that on the diagram because of the little arrows here and here. It means they're parallel. It says if the length of QD is 14.5, I'm going to label that on the diagram, 14.5. The length of BP is 9. And the length of PC is 15. Find the length of BQ, which is the thing we don't know. I'm just going to call that X. So we are going to be using the triangle proportionality theorem, which says if you have a line that is parallel to one side of a triangle and it intersects the other two sides of the triangle. So that would be PQ that we're talking about here. It's parallel to CD. It intersects BC and BD. So everything's good so far. It divides the sides into proportional lengths. What that means is instead of using, like we've done before, the entire length of the large triangle over the length here of the small triangle, we can actually say that the two parts here are actually in proportion. So like 9 to 15 is in proportion with X to 14.5. So if we write 9 over 15 and we set that equal to X over 14.5, that also will work. So instead of having to add 9 and 15 to get 24 and saying 9 over 24 is equal to X plus 14.5 over X, we don't have to use X twice, we only need to use it once. So BP over CP is equal to BQ over QD, and that's exactly what it shows right here. And so then we can substitute those numbers in. 9 over 15 is equal to BQ over 14.5, or in our case, you probably use X if we were doing this by ourselves. But then you cross multiply. So we've got 15 times X, or 15 times BQ equals 9 times 14.5. So on your calculators, what's 9 times 14.5? Or if you don't have a calculator, go get one. 130.5, okay. And then divide by 15. 8.7, all right. So BQ equals 8.7. Cool. This question over here. If BP equals 9, okay, PC equals 15, all right, that's what we got so far, and PQ equals 7.5. So imagine that the parallel length here is 7.5. Could you use 9 over 15 is equal to 7.5 over CD to find the length of CD? An interesting question. Justify your reason. Well, I think the best way to do that would be to try two different things. So let's try this first. Let's just do this real quick. 9 over 15 is equal to 7.5. I'm going to put it over X. A little bit less writing than CD. So that would give us 9X equals, let's see, 7.5 times 15 is equal to 112.5. Divide by 9, X equals 12.5. Okay, so that's one way to get it set up. Now, another way to do this would be using the small triangle and the large triangle. So we could figure out BP over BC, which would be the combination of 9 and 15, which is 24. So we could say 9 over 24 is equal to 7.5 over X. And we know that has to be true because PQ is part of the small triangle and CD is part of the large triangle. And if we do this, we're actually going to get a different answer. So that'll be 9X equals 7.5 times 24, which is 180. And if you divide 180 by 9, I think you just get 20. So X equals 20. So which one is it? 12.5 or 20? What do you think? So if we use the triangle proportionality theorem on the left that we just learned, we would get an X value of 12.5. If we use similar triangles like we did before, we get an X value of 20. Probably 12.5. How would we have done this previously? Would we have done it like this on the left or like this on the right? We would have done it like this on the right. So it's going to be this. Another way to check is because we already know what BQ equals, it equals 8.7. We could try this another way. We could say 8.7 over 14.5 is equal to 7.5 over X. And if we cross multiply here, that'll be 8.7X equal to 7.5 times 14.5. And this is using the triangle proportionality theorem again. That's 108.75. Was that? Yeah. 108.75. If we divide that by 8.7, we get X equals 12.5 again. What's that? Over here? Oh. Yeah. So this one also gives us the same answer of 12.5, but that's not the right answer. And the reason for it, so I'm going to cross those off. No, no, this is the right answer. The answer is 20. The reason why it has to be 20 is because this length of BP is part of the small triangle. However, this length of PC is not part of the large triangle. That's not an entire length of the large triangle. It's part of a length of the large triangle, whereas PQ and CD are full lengths from the small and the large triangles. Does that make sense? So like PC is not an actual full length of any one of the triangles. It's part of the length of this side of the large triangle, but it's not the full length. PQ, full length from the small triangle. CD, full length from the large triangle. Does that help a little bit? Okay. Because if you're going to compare a length from the small triangle to another full length of the large triangle, you have to use proportions that compare lengths of the small to lengths of the large, the entire length. So 9, 24, 7.5, X. Doing this one and this one, that only works with the triangle proportionality theorem, which states that we just saw right up here. It says it divides the other sides into segments of proportional lengths, the sides that it intersects with. So it says nothing about the lengths of the parallel sides. So the triangle proportionality theorem does not include the lengths of the parallel sides. It only includes the partial lengths of the sides that are being intersected. So we can only set up proportionality with the parts of the sides that are being intersected. We can't set up proportionality with the parallel side. For that, we have to use what we had done previously. Okay. Check set. In triangle FGH, so that's the large one here. FH is parallel to BC, we can see that. If the length of GB is 14.4, put that on there. The length of BF is 4.8. The length of GH is 21. Find the length of GC and CH. Interesting. Not necessarily. We'll work on it together because we haven't quite seen one quite like this yet. First of all, proportionality means that we're gonna be able to have 14.4 over 4.8 for our first fraction. Like no matter what, we can write that. 14.4. Let's just do that down here. 14.4 over 4.8. How could we work out what to do here? Any thoughts? No. I know, it's weird. Honestly, we could set it up kind of how we did initially, but we're not going to do that. So the reason why we can't write 21 is because we're not using the full length of 14.4 and 4.8 added together. So if we use all of GF, then we can include the 21, but we're not using all of GF. We're using part of it here and then part of it here. We're separating those out. So we need to separate out GC and CH. We can't really go with 14.4 because we already used it here, and that only has to do with the left side. If we don't know something, what do we usually use? Okay, so let's say that either GC or CH is X. Let's just say for this example, we use X for CH. Which means that the denominator of our next fraction is going to be X. Because that matches up with the 4.8 on the bottom of the fraction. Okay, 4.8 and X. Now, if this is X, I don't need a number right now, but how can you relate GC using 21 and X? How can you relate GC to the 21 and the X? So for example, like, let's say just complete random number. This has nothing to do with the problem, but let's say that X is 10. What's the length of GC? If the whole thing's 21 and X is 10, what's the length of GC? 11. Why? Because it's 21 minus 10. We don't know what X is. So it would be 21 minus X. Yeah, whatever GC is, it's 21, oops, not X, 21 minus X. Because if we know what X is, we would take that away from 21 to get the length of GC. Right? If X is 7, then GC is 14 because 21 minus 7 is 14, 21 minus X. So the numerator here, 21 minus X. Yeah. Mm-hmm. Is it 3 over 1? Exactly. That's, all right. We're going to cross multiply anyway, but that's an interesting fact. So it's not 7 and 14 because that's a 2 over 1 relationship. So these will be decimals as well. All right, so let's work on it. Cross multiply. 14.4 times X is 14.4X. And then remember that when you multiply the 4.8 times the 21 minus X, you have to distribute it to the 21 and the minus X. So we're going to multiply 4.8 times 21, which is 100.8. So equals 100.8 minus 4.8X. Like that. Because we got to distribute the 4.8 to the 21 and the X because that's a group. All right, then we can add 4.8x to both sides to get the x's all to the same side. So what's 14.4 plus 4.8? $19.2. Good. So 19.2x equals 100.8. So now take 100.8 and divide it by 19.2. What do you get? All right, so we get 5.25, which was equal to our value of CH. So here, for CH, we can write 5.25. Now we can take 21 and subtract 5.25, and that should give us the value of GC. All right, I'll catch you up.
Where did we get 100.8?
Because we had to cross multiply here. So 14.4 times x is 14.4x. And then 4.8 times 21 is 100.8. And 4.8 times negative x is negative 4.8. So it's just got to distribute. All right, so what's 21 minus 5.25? Because this is 21 minus x. If this is 5.25, this would be 21 minus 5.25. 15.75. Now, Zach mentioned something. He said that 14.4 over 4.8 is exactly 3 to 1. So that means we could multiply this by 3 to make that equal to that, or we could take this and divide it by 3 to make it equal to that. Does that work? Does 5.25 times 3 equal 15.75? Yeah. Cool. So I'll check it out. Any other questions here before we keep going? You'll notice the math is exactly the same as the math we've been doing. We're just writing proportions. However, we saw over here that it's very important that you're writing the correct proportions, because you can't just write any proportion you want to. You have to write the proportion based on the theorem that's being used. The proportionality theorem for triangles says that you can only write the proportions based on the sides that are being intersected. You cannot go small triangle to large triangle, because this is not small triangle to large triangle. This is small triangle to part of the large triangle, which is not the same as small triangle to large triangle. So keeping those things kind of separate, that'll be the biggest challenge. Solving the proportions, once you get them set up, that's usually the part that's less challenging. So using triangle proportions to determine if the lines are parallel. So basically, if we can show that the parts of the sides are in proportion, using the same thing we just did, if the sides are in proportion, then these two lines that appear to be parallel, we can say are definitely parallel. So let's find out. In WXY, the length of YL is 5. So there's that. The length of LX is 20. JX is 4 times as long as WJ. So anytime it relates something to smaller and larger, the smaller one should be your variable by itself. Okay, so if JX is 4 times as long as WJ, that means WJ is the shorter one of those two. That should be your variable X. JX is 4 times as long as that. That's 4 times X, which is 4X. The question here is JL parallel to WY? So all we need to do is set up a proportion and solve it. If we plug back in whatever we get for X, yeah, go on. 5. It's a 5. Sorry. Yeah, it's a 5. That was just taken from right up here, where it says YL equals 5. Yeah. All right. So what we're going to do is we're going to set up a proportion, just like we've been doing. We'll cross multiply, we'll solve. And then once we have the value of X, we're going to plug it right back in. And we're going to see if that fraction ends up reducing to the same as this fraction. If it does, that means that those two lines are parallel. If it doesn't end up equaling the same thing on, the both fractions are the same, it means it's not proportional, which means that JL is not parallel to WY. So we're going to start off by saying, you can actually prove it like this, but I would actually go with, let's just write our own. Let's just say 4x over x is equal to 20 over 5. Because that's how we'd set that up. If we're using the triangle proportionality theorem to test to see if the lines are parallel, we would go with what we did on the last page. So 4x over x equals 20 over 5. When you cross multiply, what do you end up with? You get what? 20x equals 20x. What does that tell you? Doesn't necessarily mean that x equals 0. It doesn't even necessarily mean that x equals 1. It does mean the fractions are equal, but like if we were to simplify this, let's divide both sides by 20, right? That says that x equals x. That means it's always equal, which means the fractions are in proportion. Do you guys remember infinitely many solutions from algebra 1? Where if your variables cancel out and it's the same thing on both sides, that means it always works. That's what's happening here. It's canceling out. It gets the same thing on both sides. That means x will always work no matter what, which means, if you go back over here, it means that they're in proportion because they flipped it over. They did x over 4x. But the x and the 4x, those x's can cancel out and leave you with 1/4. 5 over 20 reduces to 1/4. So they end up being equal to the same fraction. Since they're equal to the same fraction, it means they're proportional, which means that those sides are parallel. So let's try the next one. In triangle PQR, PK is 34, so let's write 34 here. KQ is 20. PJ is equal to 1.7 times the length of JR. So let's go ahead and just say right here, I'm going to say JR is equal to X because I prefer to use X. So if JR is equal to X, PJ is 1.7 times that amount. So JR is X, so I'm just going to put X here. And then next to it, PJ is 1.7 times that, 1.7 times X. And we just learned from the previous problem that we don't actually have to set up a proportion and cross multiply to solve. What you can do is we can just ask the question, does 34 over 20, question mark, is that equal to 1.7x over x? Is that the same? So if we reduce the left side and we reduce the right side, do we get the same number? Now on the right side, the x's will cancel out, and so you're just left with 1.7. So the question here is, does 34 divided by 20 equal 1.7, or does it not equal 1.7? What is 34 divided by 20 equal? 1.7. All right. So those two ratios are equal, which means they are proportional. So we can say that QR is parallel to KJ. That's our answer. We proved that those two portions were proportional, therefore KJ and QR must be parallel. All right. Questions so far? The math hasn't really changed. How we set it up is changing a bit, but the math itself, not really at all. All right. I don't see any hands up. Next, mid-segments. Now we're going to be talking about what we did in the warm-up. So if we're dealing with mid-segments, we just talked about this in the warm-up, so we'll be able to maybe move a little bit quicker through this section. Mid-segments and parallel lines. Here we go. A mid-segment of a triangle is a segment that connects the midpoints of the legs of the triangle. So RQ is a mid-segment because it connects the midpoints of CB and AR. The midpoint of CB is Q. Listen up. Midpoint of CB is Q. Midpoint of CA is R. Connecting those two makes a mid-segment. RP is another mid-segment. It connects the mid-segments of CA and AB. P is the mid-segment of AB. R is the mid-segment of CA. Those are connected. It's a mid-segment. QP is another mid-segment. Every triangle has 3 mid-segments. There they are, just drawn in the middle. The mid-segments of the triangle are RP, PQ, and RQ. One special case of the proportionality theorem is the triangle mid-segment theorem. So this is a special case of the proportionality of the triangle proportionality theorem, and it says that a mid-segment of a triangle is parallel to one side of the triangle, and This is what we saw in the warm-up. Its length is half the length of the side that it does not intersect with. For example, here, JK is equal to half the length of GF, or GF is twice the length of JK. You could, think of it either way. Any questions about that? Good so far? Okay. So if you know you have a mid-segment, by the way, we know this is a mid-segment because JH is congruent to FJ. That means that J is in the middle of F and H. Same thing here. HK is congruent to KG, which means that K is the midpoint of HG. The midpoints are connected. Therefore, not only are these parallel, JK is half the length of FG. All right. Another special case of the triangle proportionality theorem involves 3 or more parallel lines cut by 2 transversals. So that is what we see next. This one right here says, if 3 or more parallel lines, we have 3 parallel lines, AE, BF, and CG. Those lines are all parallel because they all have the parallel symbol on them. If they are intersected by 2 transversals, here's one transversal, here's another transversal. So those 3 parallel lines are intersected by 2 transversals. That means they cut off the transversals proportionally, meaning the relationship between AB to BC is going to be equal to the relationship between EF and FG. It's basically exactly the same thing as the triangle proportionality theorem, except if you were to highlight this shape, it wouldn't make a triangle. What shape would it make? Trapezoid, yeah. And a trapezoid, all a trapezoid is a triangle with like the top cut off. Right? Like if I was to draw a trapezoid, if we were to continue like that, we would eventually have a triangle. So trapezoids are essentially triangles that have part of them cut off. So AB to BC is equal to EF to FG, which is exactly the same thing as the triangle proportionality theorem, except it's not being used with a triangle here. It's technically being used with a trapezoid. But the math is the same. All right, the last one we're going to look at today is another property. And this one here says, congruent parts of parallel lines says that if 3 or more lines cut off by congruent segments on one transversal, then they cut off congruent segments on every transversal. So what this means is, if you draw, I'll just show you an example here. If you draw 3 parallel lines like this, you don't have to draw these. But if you know you have 3 parallel lines, yeah. If you know you have 3 parallel lines, and let's say I just draw a transversal like that, okay? And this particular transversal makes congruent segments here and here. What we're saying is that if that can be shown, any other transversal that we draw through it will also create congruent segments in between those parallel lines. So if we were to draw a line diagonally from here all the way over there, like that, these segments would also have to be congruent. Which kind of makes sense, because if the distances between 3 lines are the same, it doesn't matter what way you draw a line through it, those segments will be equal to each other because the lines are all the same distance apart from each other, right? Makes sense. Okay, so what we're saying here is that if you have 3 parallel lines, they're all spaced evenly. That's basically what we're saying. And you got this transversal that makes AB congruent to BC. That means that this transversal over here, EF, has to be equal to FG. And any subsequent line that we draw through them, any other transversal that you could draw through here, will create congruent segments in between those 3 parallel lines. So let's do some math with all those things. Starting with the triangle mid-segments. All right. We've got 2 mid-segments here. We have FE and we have DE. Those are mid-segments. In the figure, EF and D are midsegments, okay. Find the length of DE. Here's DE. DE is parallel to AC, which means that DE is equal to half the length of AC. Since AC is 15, DE is equal to half the length of AC, which is half the length of 15. What's half of 15? 7.5. DE equals 7.5. That's it. Just out of curiosity, what's the length of AB from that same triangle? Yeah. Which equals 18.4. Yeah, AB is 18.4. Because the mid-segment that it's associated with, FE is 9.2, double that, 18.4. That's it. All right. So let's take a look at the check step down here. In our figure, FG, GH, and FH are mid-segments, which means that they are parallel to the sides that they do not intersect with, and they're also equal to half the length of the sides that they don't intersect with. So let's start off. What is the length of AC? AC is here. Which one is it parallel to? GH, yep. This is half the length of that. 32.5. Nice. AC is 32.5. All right. CB. How long is CB? 28. FH is the side it's parallel to. FH is half the length of CB. CB is 28. The length of AH. Was it? AH? Yeah, AH is going to actually be equal to the length of the midsegment because H is the midpoint. FG is equal to half this length here. So AH and FG are actually congruent. So AH is 19.5. What about AB? That's the one that Leo was answering for. So how long is AB, Leo? That one's 39. Good. And then CG. 14. Nice. Cool. Questions there? Great. Let's keep going. I think we only have one more page. Yeah, we're getting close. Pretty quick today. All right. Here we go. So again, this is another usage of the corollary. Corollary is an extension of. That's what that word means, corollary. So it's an extension of the proportional parts of parallel lines, which in this case essentially looks like a trapezoid. So it says, all right, use proportional segments of transversals. A developer is looking to purchase lots 18 and 19 on the lake and wants to determine if the lengths of the property's boundary that runs along the lake measurement known as frontage. Find the lake frontage for lot 18 to the nearest foot. So the lake frontage for lot 18, that's going to be the value of X. So it gives us numbers here. The lake frontage for lot 19 is 120. The length across the back of lot 19 is 102. The length across the back of lot 18 is 96.5. We want to find the lake frontage length for lot 18, which is marked as X. And it does, it tells us setting up everything. It gives us information about the corollary, all that. This is basically using the triangle proportionality theorem, but we're using it with essentially a trapezoid instead. So you can take the frontage that we need, X, put it over the length that's adjacent to it, 120. That proportion or that ratio will be equal to the ratio of 96.5 over 102, which is exactly what it shows here. So setting up the proportion for this one here, X over 120 equals 96.5 over 102. Cross multiply. We would probably actually say 120 times 96.5 and then divide by 102. It's all the same math anyway. Anybody have it? I would say it's going to be more than 100, but less than 120. No, because we're working. We're thinking. Oh. Yeah. What'd you get? 142. I did 120 times 96.5. Yeah. Oh no, don't multiply them by both. Yeah, because if you multiply them by both, that would be multiplying, that would be 120 over 120, which is the same thing as 1. Yeah, so just do the 120 times 96.5 and then just divide by 102. There you go. 113.5. That makes more sense. All right. One more problem, then we're done. Then you got your assignment, and we'll get out of here in about 22 minutes. It is due Monday, yes. It will be due Monday, yeah. All right. By the way, 8.4, if you haven't turned it in already, that one is due today. All right, here we go. Last one, number 5, example 5. We're gonna be using congruent segments of transversal. So if you have 3 lines that are parallel, and you have a transversal that cuts through the 3 parallel lines and it creates congruent segments, which we have here, that means that any other segments that are cut by another transversal also must be congruent, which means that AB is congruent to BC. We are not stress this enough, we are not writing a proportion to solve for anything here. We could, but we're not. And in fact, we shouldn't, because if we did, we would end up with multiple variables on both sides of the equation. When we cross multiply, it'd be really messy. But because we know that these two are equal to each other, that means that these two are equal to each other. So let's just focus on setting the two expressions with x equal to one another and then solving for x. So not everything we do right here is going to use proportions. Most things will. These ones won't necessarily. Yeah. These ones won't necessarily use proportions. We can just set those two things equal to each other because those two segments are congruent, which means AB is equal to BC. So if you're setting AB equal to BC, that means that 2x plus 8 is equal to what? 12. 2x plus 8 is equal to what? 7x minus 12. Nice. All right. From there, it looks like 2x was subtracted from both sides. So if you take away 2x from 7x, what do you get? 5x. 5x. All right. Then if we add 12 to both sides, 8 plus 12 is? And then if you divide by 5, what does x equal? 4. Great. X is 4. We can do the same thing to solve for y. We take 4y minus 1, set it equal to y plus 8. This time it looks like they're subtracting y from each side. So 4y minus y is 3y. Add 1 to both sides. 8 plus 1 is 9. 3y equals 9. Divide by 3. What does y equal? 3. There you go. Basic algebra. Cool. That's it. The math rarely changes. The way we set it up changes, but the math that we do doesn't really change. All right. That's it for your notes for today.